This is our set of double replacement reactions that happen in aqueous solution. In the first three test tubes on the left, I have a solution of barium chloride. The fourth test tube, the blue solution, is copper 2 chloride. And the last test tube on the right has a solution of ammonium sulfate. The first reaction we're going to do is combining the barium chloride with lithium carbonate, and when we do that, we see the immediate formation of a white looking solution. It's actually a very fine white powder that will form a solid precipitate at the bottom when allowed to settle. The second thing we're going to react is the barium chloride solution with some ammonium sulfate. We can see this one makes a very thick, heavy white precipitate, much more so than the first one. The last reaction we're going to do with barium chloride is a reaction with potassium hydroxide. One of the products we would expect to be formed here is barium hydroxide, which, if you look on our solubility chart, says it's soluble in water. But when we do the reaction, it's quite clear that a precipitate immediately forms. This is because barium hydroxide, while it is soluble in water, is only slightly soluble in water, and we wind up with a barium hydroxide precipitate that cannot dissolve in the amount of solvent we have in the test tube. Our fourth reaction, we're going to react the copper chloride with potassium hydroxide. And when we make that reaction happen, we get a very, very deep blue. And if you look at this, it almost has the appearance of a gel that forms inside of there. Our final reaction is going to be the reaction between ammonium sulfate in the test tube, and I'm going to add potassium hydroxide to that one. When we do that, as expected, we see absolutely no change in the solution. And that's because the products that we form, which are ammonium hydroxide and potassium sulfate, are all soluble in water, which means we've gone from the same ions as the reactants and the products on both sides of the reaction. In that case, everything stays dissolved, and the net ionic equation shows that everything is an ionic species both before and after the combination. It's been a couple of days since I did my double replacement reactions, and the precipitates that they form as a powder, and it really looks like we've just changed the color of the solution. But given enough time, gravity will pull those little particulate pieces down to the bottom. So we can see right here that all three of our double replacement reactions were solid precipitates that have sunk to the bottom, leaving us a clear solution at the top. The fourth one, the copper chloride and potassium hydroxide, this one has not been sitting as long. I had to do a separate reaction because I accidentally cleaned it up. This one's only been sitting for about a day, but it's still clear that the solids are gently settling to the bottom as time allows.